Next example, now this one is using a unique time interval. It says a bacteria colony doubles every 5 days. So doubles is key. It's giving us the fact that's the growth rate is 2. And then it's doubling every 5 days. So this is a scenario where we're going to have to use a unique exponent t over k, right? So we know it's doubling, so we're going to say b is 2, and we know it's every 5 days instead of every day. So we're going to have a k value of 5. And then we're going to structure our exponential growth equation. A of t equals ab to the t over k. A is 200, right? That's the current population. That's the original size of the population. Growth factor is 2, and then to the t over 5 exponent here. Now the question is saying in 20 days. So that means t equals 20. So we're going to plug 20 into t here. 20 divided by 5 is 4. 2 to the 4th power is 16 times 200 gives us 3,200 or 3,200, right? So the population of this bacteria would be 3,200 in 20 days. Next example, if $1,000 is invested at 8% per year, in about how many years will the investment be worth $2,000? Okay, this is a problem where you can strategize, right? If you kind of like looking at different ways to answer this question, right? So this is an approximation, it's not an exact. And if you pay attention to the numbers, the initial value here is 1,000, the final value here is 2,000. 2,000 is twice the value of 1,000. That should be a hint for you to potentially look at the rule of 72 because it's doubled now. So 2,000 is twice 1,000. Use the rule of 72. Your R value is 8%. So that's just 72 divided by 8, leaving us with 9 years. So this investment will take about 9 years to double in size. Next up, the value of a house is increasing at a rate of 14% annually. Find the value of a $100,000 house in 5 years. How many years will the value of the house be approximately doubled of what it is now? Okay, so again, there's that doubling concept, right? So let's answer the first part. Find the value of a $100,000 house in 5 years. That's the original value of the house, $100,000. Your R value is going to be 0.14. That's an annual per year growth rate here. Excuse me. Yes, growth rate. And we're going to first set up our equations. So I have my A of t equals A sub 0 times 1 plus R to the t. A of 0 is 100,000. That's the original value of the house. My time interval is 5 years, and my R value, the growth rate is 14%. Your R value is actually 0.14. We're going to plug that into my equation, and that's going to give us 100,000 times 1.14 to the 5th power. Carefully calculate that. And that'll give us approximately 192,541 in 5 years, right? Then it goes on and asks for, in how many years will the value of the house be approximately double it is right now, right? So that's the rule of 72. So what we can do is we can take 72 and divide it by 14%, and that's going to be about 5.14 years, right? So in how many years will the house be approximately double? 5.14, we're dividing 72 by 14 here. That's the rule of 72, and that's the approximation. Alternatively, you could take this equation you created right here, set it equal to twice 100,000, right? So that's 200,000. And then solve for t, right? So it's not 5 when you're doing this, it's t, and you use a logarithm to solve for t. Now, those values will be different because the rule of 72 is much more of an approximation than this analytical step here.